Good morning, students. Today we are going to start a new chapter, chapter 5, that is continuity and differentiability. First of all, we shall discuss about continuity of a function. But before that, we need to review the limit of a function what you have read in your class 11. Now let us have a quick review. Some formulae on limit. What is first formula? Limit x tends to a x to the power n minus a to the power n by x minus a is n a to the power n minus 1, where a is any real number. Then limit x tends to 0 sin x by x is same as limit x tends to 0 tan x by x is 1. Number 3, limit x tends to 0 e to the power x minus 1 by x is 1. Fourth, limit x tends to 0 ln 1 plus x by x, it is 1. Then fifth, limit x tends to 0 a to the power x minus 1 by x is ln a. And when we call a function's limit exists, limit x tends to fx exists if it is unique. That is, left hand limit is equal to right hand limit. And how I find left hand limit? Left hand limit, how we find? That is limit x tends to a minus fx. It is same as what it is? Limit h tends to 0 f of a minus h. And how we find right hand limit? It is limit x tends to a plus fx. How we get it? Limit h tends to 0 f of a plus h. I think you are understanding the things. Then question arises, when to find LHL and RHL, that is, where there is a chance of non-existence of limit. If the limit is defined or the function is defined differently in different intervals, in that situation there is a chance of non-existence of limit. Okay, so you have read this much in your class 11. Now coming to the continuity of a function. Continuity of a function at a point. We must have a basic idea, we must have a feeling of continuity. What do you mean by continuous function? Let us consider the graph of a function. This is its domain, you see, and this is another graph. This is 0, 1 and this is 0, 2. Then let me take another graph. Next, let me take another graph. You see the differences. Here, for every value of x, I get a y, and there is no break in the graph of the function. So, continuity meaning is, what is the dictionary meaning? There is no gap. This is continuous. here you see, in this situation, there is a break, jump in the function. Here, this is the point where it is not continuous. Here, this is the point where it is not continuous. Here you see there is a gap, and at this point, function's value is here. Therefore, here is not continuous. Now from these figures, let us discuss let us feel the meaning of continuity or discontinuity. So what is the meaning of continuity of a function? The function's graph must be continuous. There should not be any break or any jump in the function. But in this case, what happened? When x is 0, I am getting this one is y equal to 1. This is y equal to 2 or fx equal to 2, and here it is fx is 1. But when x becomes 0, here it is a gap, so that function jumps to 2. Means the value of fx in this situation I am discussing. What is f of 0? When x is 0, fx is 2. So f of 0 is 2. And what is left hand limit? As x tends to 0, the left hand limit is obviously 1. This one is left hand limit. So LHL 1. And what is RHL? It is 2. So left hand limit not equal to right hand limit means limit does not exist here. But a function has a value at that point x equal to 0. Function has a value, limit does not exist. In this situation, come to this situation. Here this is f of, this point is say 0, 2. Now what is LHL? This is 0, 1. Okay. LHL as x tends to 0, this is x tends to 0. LHL when x tends to 0, it is 1. RHL when x tends to 0, it is 1. But f of 0 is 2. So in this situation, limit exists, but that limit is not the value of function at that point. Here LHL is equal to RHL. So limit x tends to 0 fx is 1 in this situation, because LHL is equal to RHL equal to 1, but f of 0 it is 2. Therefore the limiting value is not equal to functional value. So the basic concept in this situation, LHL is something else, RHL is something else, but function is not defined at this point. So at this point the function is not defined, means it is discontinuous. Therefore from this discussion we conclude a function f will be continuous when the limit exists and the value of that limit must be equal to value of the function. For example, this point you see, LHL same as RHL, same as value of the function. So in this situation we say the limit exists and the value of function is same as value of limit. This is the basic idea about continuity of a function at a point. Now coming to our final conclusion. A function y equal to fx is continuous at x equal to a if limit x tends to a fx is equal to f of a. Now question arises. Can I find this limit always? Sometimes there is a break in the function. For example, say, let me take a simple example for this. Say fx is equal to mod x. Okay, absolute value of x. And I want to check continuity at x equal to 0. Now you see, what is the definition of mod x? It is x when x is greater than or equal to 0 and minus x when x is less than 0. Now, what is the condition of continuity at a point? First I find fa. Here a is 0. I will find fa. Then what is f of 0? Obviously it is 0. This one, put x is 0 here. X is greater than or equal to 0. It is x. Next, what is LHL? Limit x tends to 0 minus fx. That is, limit h tends to 0 f of 0 minus h. 0 minus 0 से कम है. Limit h tends to 0. What is it? This one. It is minus h. And what is it? It is 0. I can write this directly. हम इसको भी ऐसे लिख सकते हैं. That is, limit x tends to 0 minus fx. It is limit x tends to 0 minus x. I can write in this. It is 0. And next, what about RHL? It is limit h tends to 0 f of x tends to 0 plus fx. It is limit h tends to 0 f of 0 plus h. And what it is? Limit h tends to 0. What it is? X. It is 0. So we got LHL equal to RHL equal to f of 0. All are 0. So what is the conclusion? F is continuous at x equal to 0. Okay, and in our next video we will take more examples on continuity of a function.